All right, so today what we're going to do is we are going to make a gearbox plate similar to this one. I eventually, hopefully you can expand it beyond this, but basically something that is able to hold a motor and be sized appropriately for a pinion motor and a spur gear. So we're going to talk a little bit about how we do those types of things. So first thing, like usual, is you're going to open up whatever session it is that you do, and you're going to create a new folder, and you're going to rename it to your name, and you're going to go into your folder, and you're going to create a part studio. I'm going to go ahead and rename this as well to Andrew Gearbox. All right, so I want to remind y'all a little bit about some of the things that we did and introduce some new concepts about sketches and extrusions before we start building a gearbox. So just like last time, we're going to click the sketch icon up here in the toolbar up top. And as a reminder, you can select all the different planes, whichever one you want to build the gearbox on. You can also select it from the feature tree on the left here. We're going to do it on the front plane. And you can right click and do view normal to sketch, or you can hit the N key on your keyboard and it should rotate it so you're viewing normal to the sketch plane. So I want to remind you all of a couple of things. When you enter into a sketch, you have different icons that show up in the toolbar here. We primarily use lines, rectangles, circles, arcs, the inscribed polygon, and the points. And so if you do a rectangle, or any part, when you are making your sketch, you'll see that some things will turn orange, and that is if you're getting a constraint somewhere. So you can see that in this case, I get an icon that is a horizontal line because it is going to constrain it to being horizontal to the origin. Or I can move up here and it is going to constrain it to being vertical to the origin. Or if I go here, this is called coincident, and you can see it even gives me a box around it. Basically, coincident just means on top of. And so if I do it over here and there's no orange, and I make a little rectangle, I'm going to right click and do escape from rectangle, or you can hit the escape key on your keyboard. And you can see that I can drag any one of these four corners or the line itself, and I can change the shape of the rectangle. If I wanted to start constraining things, this is going to be where these icons at the top of the toolbar come into play. Coincident, as I mentioned earlier, is a point is on top of another point. They share the same location. We can have concentric, which is when an origin or a center of a circles line up on top of each other. If you've had geography, I'm assuming parallel, tangent are things that make sense to you. We use tangent if we want two circle edges to be lined up on top of each other, or a circle and a line to be tangent to one another. If we want points to be in the same horizontal line, the same vertical line, or if we want two lines to be perpendicular to each other, if we want lines to be equal to each other. These are all common constraints that we use. Additionally, if we hover over a line, we can see what constraints are already on that line. So for instance, if I hover over this line on the left, you'll see that it brings up the two constraints that it has. It's perpendicular to the line on top, and it's parallel to the line on the right. So if I come here and I delete that parallel line, now I can make it so that that box is no longer parallel. I can come and add that parallel constraint and say that I want these two lines to be parallel again and make them parallel. So also as a reminder, if you want to do something, you can start, and as long as your sketch is completed, you're going to have a shaded region. If for some reason you have a line that is missing and it's not a closed shape, you'll see that that shaded region goes away and it's no longer a closed shape, and you can no longer extrude it. If I were to try to extrude something, there's nothing for me to extrude. I can't extrude any of these things here. So let's go back into the sketch, take a line and close the shape. And now it's shaded again. So if I wanted to, I can come and I can extrude this part some distance. I'm going to leave it just at the 1 inch for now. Some other things I want to point out is that we use something called construction lines kind of frequently. And so construction, you can use the keyboard shortcut of Q, and you can come and you can change individual lines to a construction line. You can select anything that you want to be a construction line and change it to a construction line. And it changes from a solid line to this dashed line. And what that dashed line means is that it is not part of something that you actually want to extrude or do anything with, but it's just a reference geometry that you might use. Something that as you're sketching things, you want to know what something looks like or the shape or distance that something has, but isn't actually being used. If I complete this, you'll see that because this is a construction line, the extrude no longer works. It is there's an error. It doesn't regenerate properly. There's nothing to extrude because it's all construction lines. So I'm going to go ahead and select all of these construction lines, change them back, and let it complete and be extruded. That is kind of a quick refresher on a couple of things. Let's go into the sketch. Let's add some constraints. So as I mentioned before, these lines are blue because there are not constraints. It's not fully defined, so you can move them around. Something we can do to start adding some constraints is if we want a corner to be coincident with the origin. So I can select this point and the origin, and those points are coincident. And then maybe what I want to do is I want to come over here and say I want this dimension to be 4 inches, and maybe I want to select this to be 2 inches. Just to point out what I did is this is the dimension tool, and so you can use a keyboard shortcut of hitting the D key to set it. And so now that I've set the dimensions of these guys, this is still not parallel. Let's go ahead and make this parallel again. So now that those lines are parallel, these all turn black. And because everything is black, what that means is that this is a fully defined sketch. And so I can't modify anything anymore. If I delete this dimension, we'll see that it is no longer fully defined, and that's because I can change how tall it is because I don't have a dimension for how tall it's going to be. The line is black all the way up to this point. You can see that the point is blue because the end point isn't fully defined, even though the line is fully defined. So I'm going to hit the D to change this and make it 2 inches tall. It's fully defined, so all the outside edges are black. The inside area is fully shaded in. If I complete the sketch, it extrudes just fine, and it is extruded the 1 inch. So that's a little bit more detail into some of the things that we did earlier this week. You'll notice that if I am in a sketch, I have a different toolbar up top. So this is I've got the line, the rectangle, the circle. I've got the different constraints of coincidence, concentric, parallel, etc. If I am not in that sketch toolbar, I have this toolbar for the extrusions and some other things in here as well. Most of these things we aren't going to worry about right now except for the extrude. But one of the things that I wanted to introduce briefly is variables. So before we do variables though, go ahead and pause the video. Just go ahead and make a sketch of a rectangle and extrude it. Make sure that it is a fully defined sketch. So go ahead and pause and then come back once you're done. Alright, I'm going to assume that you have paused the video and done that. So I want to introduce variables. So I'm going to make 3 variables. I'm going to call this one width. And let's make this be, we'll make it 3 inches. And I'm going to make another variable called length. And we'll make this one 5 inches. And I'm going to make a final variable called depth, and we'll make this 10 inches. It doesn't really matter what these dimensions are. So these are called variables. If you went to any of our programming lessons, you'll know that these variables are things that can be used to I don't know, modify things that already exist. And you can go and just modify this, and it should hopefully do other things elsewhere. You'll notice that this feature tree, there's a timeline to it. So the sketch was made, and then the variables were made afterwards. A nice thing is that I can drag and drop things into different locations. So if I drag and drop the width before the sketch, if I go into the sketch, you'll see that I can go, and instead of having it be 4 inches, I can say that I want it to be the width variable. And I can type WID, it automatically changes it to the variable, and it changes it to whatever the width is equal. But because length was defined after sketch 1, I can't type length. If I try to type length, it doesn't work. It doesn't know what it is. And so I can exit out of that. I'm going to go ahead and accept this. And I'm going to move my other variables up above the sketch. And so now maybe what I want to do is, let's say, make this one be the length. We'll make this one be the width. I think this didn't save length. And then you don't have to limit to only using the variables in these sketches. You can use it for the extrude as well. So I can come into this depth position here, and I can use depth variable here, and you'll see now that the box has changed its shape. And so the nice thing about variables, this is called parametric design. And so if you're smart with some parametric design, you can set the variables up so that you can modify what your design looks like without having to go into the extrusion or the sketch and change things in particular. So maybe I want to make this be a cube. So I can go and I can change the width to equal 2. I can change the length to also be 2. And a cool thing is that you can even set a variable to be something related to the other variable. So I can come in here and I can type in width, and I can have it be width. I could do width times 2 if I wanted to even. So I could do that, and you can see it's not really a cube because it's too deep, but I can come and just make it width instead. And now it'll be a cube. Or I can come in here and I can make this be 20 inches long, and you'll see that it is extruded much further. I can make the length be 40 inches long, and it'll change it again. And so parametric design is kind of a nice way to be able to modify your design without having to modify the actual sketch. You can see that the sketch would be modified. It is using still the variable that you used before. So why don't you go ahead and pause the video here and go ahead and mess around with variables a little bit, extruding a cube and a sketch, or you can do other things besides a cube or a rectangle or anything like that. So go ahead and pause and come on back. All right, I'll assume that you've paused here and have come back to the video, completing that. We're not going to use this Part Studio anymore. You could delete everything here, but we'll leave it. I'm just going to create a new Part Studio, and I'm going to call this Part Studio Gearbox. I'm going to call it Andrew Gearbox because that's what we want to design here. So before we go too far into the Gearbox, what I want to do is show you some things about gears because they become relevant here. So I can go to paradox5414.weebly.com/training.html, and I have a intro to gears slide deck here. So if I select this, I'm going to go just a couple of slides in. We're not going to go through the whole thing, but I want to note for y'all that the reason that we use gears is to either change where the force is at, or we can change the speed and torque of it with a desired ratio. So if we have a gear on a motor that is 1/3 of the size of an output gear, what ends up happening is that in order for this one to turn, say, 3 times, this one has to turn, if we want this one to turn 1 time, this one has to turn 3 times. And so this ends up going much slower, but it also has more torque, which is something we'll talk about at a later date. So we use gear ratios to either change the speed or change the torque available. Sometimes we also do it to just move where the force is at. You could have a 1-to-1 ratio where the speed and the torque stay the same, but the force changes from this center point to this center point. And the other thing that I want to talk about with gears is that an important thing in it is the pitch circle or pitch diameter. We use primarily something called diametral pitch of 20. And what that means is that if you want to calculate the pitch diameter, you can just take the number of teeth divided by the diametral pitch, and you'll get the pitch diameter or the pitch circle. So in this particular example here, there's 36 teeth, and the diametral pitch is 24. And so if you do 36 divided by 24, you get 1.5 for the circle here. And what this circle is important for is that if you had another gear, you want their pitch circles to be tangent to one another so that you can transfer torque from one gear to another. In reality, most of the time when we do these, we don't actually make them tangent. We have a small offset between them. But we'll worry about that in a later training session, or maybe you want to figure it out on your own and or ask a veteran student about that. So at any rate, the important thing is take the number of teeth divided by the diametral pitch, and that is your pitch circle. And you want the pitch circles of two gears to be roughly tangent to one another. There's a lot of other things in these slides. If you want to review them on your own time, that's perfectly fine. Okay, so we are in a Gearbox part studio here. I'm going to kind of give you some information. In a normal build season, you might need to calculate this or figure out what it is that you want to use. But it's okay for right now that we will just make some assumptions, and then we'll teach you later about how you come to those assumptions later. So I'm going to start a sketch on here. I hit the N key to view normal to the front plane like before. So we're going to do something called a master sketch. A master sketch just has several things on it that are relevant to the geometry of what we're doing. It's not super important in this particular example, but we're still going to do one anyways. I'm also going to pull up, if I go to vexpro.com, I want you to see what it is that we are going to be utilizing. So I can go to motion. Nope, I want to go to motors. Where are motors at? I may have missed them. Here we go. We want to look at the sim motor, or really we want to look at a mini sim motor, but that's fine. They're both very similar. If I go to the mini sim motor, you can see that this motor has a flat edge here, but there's a small diameter circle here that extrudes past it, and then there's a shaft that comes out that a pinion gear goes on. And you can see that there are two holes that are used to attach the motor to a plate, or however it is that you're trying to attach the motor to it. If you scroll down a little bit, you can see that there is a drawing, and you can right click and open that up in a new tab. We can also go and look at a couple of different gears. So if I go to the motion and gears page, you see that there are 20 diametral pitch motor pinions and 20 diametral pitch half hex bore gears. So we're going to be using these today, and I'll talk about that a little bit later. If we look at the motor drawing, I want to point out a couple of important things. You'll see that the part that extrudes out from the motor here, if we follow these lines over, there's these arrows here between that show that it is 3/4 of an inch wide. Drawings are a little unusual to read if you haven't done it before, so this is a little confusing. That is okay for now. We'll help teach you how to read drawings at a later time. For now, just know that we need a hole that is 3/4 of an inch wide for the motor to be able to sit flush. So we can go back to our sketch here, and we're going to say that we need a circle that is representative of our pinion gear. And because we're not actually going to do anything, make a part based on the pinion gear, we're going to make this a construction line. And so, like I mentioned before, we can hit Q and it'll change it to a construction line. We also want to make several other concentric circles. So you can see right now as I hover over this that it would be vertically in line with a circle above it. But really I want it to be coincident. Alternatively, you could do concentric. So if I wanted to, I could make a circle out here and make it be that 0.75 that I was talking about and use the concentric tool to make these circles be in line. But I don't necessarily need to do that. That's a little bit slower. I could instead just hover over here and make these circles. I'm going to make a construction line. I'm going to make two more that I'll talk about in just a moment. If I look at the motor here, you'll see that there is a bolt circle that is 2 inches in diameter. And if we follow this line up here, we can also see that it is intended for 1032 bolts. And we can look at the motor page as well and see that this motor is 2.5 inches in diameter. So I'm going to come into here. Next to the constraints is the dimension tool. You can use D as a shortcut, and this sets a dimension for whatever it is that you click on. So we've got a dimension for the outside edge of the motor. We know that the motor diameter is 2.5 inches. We know that the diameter of the bolt circle is 2 inches. We've already created a diameter for the 0.75 inch for the motor. And then the last thing that we need to set is for the pinion. And I'm just going to let y'all know that we are going to use a 12-inch pinion that is a 20 diametral pitch. So what I want to actually do, I'm going to complete the sketch for now, and I'm going to realize that I want to create some variables. So I'm going to say pinion teeth, and I want this to be 12. And so you can see you can leave it as length as 12 inches. That would be okay. I'm going to change it to number because it's not really inches for the number of teeth. And I'm also going to just go ahead and let y'all know that we're going to use 82 teeth for, whoops, I don't need that as a name. I'm going to say spur teeth, and I'm going to say 82 for that number. And I'm also going to create a variable called dp for diametral pitch, and that's going to be 20 as a number. Again, you can leave all of them as length. That would be okay. I'm going to change them all to number just because they don't really have a unit associated with them in this context. But I need the sketch to be below these three variables because I want to use these variables in the sketch. So if I open the sketch back up and I hit D to change the dimension of this innermost one to be representative of the pinion gear, I can go pinion teeth divided by dp and hit enter, and you'll see that that automatically changes it to the 0.6. If we did 12 divided by 20 in a calculator, you'll see that that is also 0.6. So those two things line up exactly how we would expect. And then, as I mentioned before, we're going to use an 82 tooth gear for the second part of our gearbox. So I'm going to create another circle. I'm going to put it at the origin. So I've got an orange box around the origin. So it's going to be coincident with the origin. I want it to still be a construction line because we're not going to extrude anything related to this. And I'm going to hit escape, or you can also hit right click, escape from circle. And I'm going to dimension this. And just like before, I'm going to now say spur teeth divided by dp. And hit enter. And you'll see that this is the size of the spur gear. So this has no relation still to our spur gear because there's no constraint between these two different things. All four of these circles are concentric through the coincidence or the concentric constraint. And as I mentioned before, if we want two gears to be lined up with one another, more or less we want them to be tangent with one another. So I can hit this tangent constraint. I want it to be with a 0.6 because that is our pinion gear and the spur gear. So I want these to be tangent with one another. You'll notice I'm going to hit escape. You'll notice it is still not fully constrained. I can move this around, but it is now at least tangent to the spur gear. One way we can fully constrain it is if we say we want it to be coincident with the horizontal line, or I'm sorry, the vertical line going straight up from the origin. We should be able to do that, but maybe I need to do something a little bit more. If I come and do coincident with this line, I did not like that. Let's Control Z to undo. I'm not sure why I didn't like that. There we go. So now the origin is vertical. I'm sorry, the origin of the circles is vertical with the origin here. Now everything is black. So it is a fully defined constraint. So if we look at this and we consider it the master sketch, I can even come into here, click this pen, and change the title of it to master sketch. You don't have to do this. I'm just doing it to demonstrate that. We have a bunch of construction lines representative of the motor and the pinion gear and the spur gear. And so what we'll do now is create a new sketch still on the front plane, but we want to use some of the important pieces from this. So I can come into here and say, well, I want my gearbox to be the size of the spur gear and the size of the motor. And I can either right click and hit use, or I can hit the U key on my keyboard and it should pull those in. So I can hide the master sketch and you'll see that these two construction circles still exist. If I could, but I don't actually want these to be construction circles anymore. So I can select both of them and I can hit this construction in the toolbar, or I can hit the Q on my keyboard and it'll change it back to normal. So if I hit the green check mark temporarily here, you'll see that it has completed the sketch. I could even come and extrude these parts here, and you'll see that it does have something. It's basically a little snowman, right? But the unfortunate thing is that we would never want to actually cut anything like this. So let's go back into the sketch and let's make things a little bit better. And actually, I'm even going to go back into the master sketch because I realized I don't have the bolt holes for the motor here. So I'm going to use the point tool in the toolbar here. And one of the things you can do is if you want it to be horizontal with the origin, if you start at the origin and move to the side, you'll see I've got a dashed line here that is keeping it horizontal with the origin. And now the circle is lined up with a 2-inch circle, so it is coincident with that. And so I can do that and get these lines horizontal and in line with the sim motor here. And so I can use those points later. So I'm going to hit the green check mark to complete the master sketch. I'm going to go back into my sketch here. And there's a couple of things more that I want to do. I want to have a hole big enough for that part of the motor to come through. So I'm going to use this. And I want it to be not a construction line. Also, I'm just going to let you all know that when we use bearings, it is a 1.125 inch circle. So I want a hole for a bearing here. So I'm going to create this and make it 1.125 as well. And then if we wanted to manufacture something, let's hit the green check mark here. If we wanted to manufacture something, you can see that it would be very tough to manufacture this snowman shape here. It'd be much easier if this is just a straight line where that line is tangent with these two circles. So let's go back into the sketch. Let's add a line here that is right now not going to be tangent to these circles. I'm going to hit escape and then add another line over here on this side. and then hit escape. And then so I can use the tangent constraints, and I can hit the line and then the circle, and then hit the line and then this bottom circle. And now this line is now black because it is tangent with both the top and the bottom circle. So I'm going to do the same thing on the right hand side. All right, so I probably should have stopped earlier for you all to go ahead and get this far. If you haven't yet, go ahead and make sure that you make the master sketch, pause and come back, and then go ahead and do this. Once you've done this, go ahead. The next thing we're going to do is we're going to take advantage of this trim tool. So again, M is the shortcut because it's in parentheses, but we just need some of these lines on the outside. If you've noticed when I was doing the extrude, I had to select multiple parts because there are multiple enclosed areas. So I can use the trim tool, and these things that are inside, I can trim them. So I can click them and it basically removes them. I just need some of these lines on the outside. So I'm going to do that to trim some parts. And now when I hit the check mark, because it's already extruded, it does that. But if it didn't exist, if I just had this sketch, I wanted to extrude. And if you want to, you can hide the master sketch. Just make sure that it is clear as possible what it is that you're extruding. I could come here and just select this outsides part. I'm going to make it just be 0.25 inches. So now this is a 1/4 inch part. Now, whenever you extrude a part, it automatically hides things before it. But we're not totally done with this sketch one. Go ahead and pause if you haven't to make sure that you get to this point. Since we're not done with the sketch, we want to unhide it. So I'm going to check this eyeball here so that we can see the sketch again. I'm going to view from the front. And there's this hole tool. Let's go ahead and check and make sure this sketch is missing it. Let's unhide the master sketch tool as well. We want to use these 2 points here. So I'm going to select those two and hit U to use them. And then I'm going to hide the master sketch. And I'm going to use this hole tool. So far we've only used sketch, extrude, and now I'm introducing the hole tool here. And this is handy for a number of different cases. You can do this on a point and a point only. So I'm going to select these 2 points. And you can change what kind of bolt it is intended for. If we look at this again, this was a 1032 bolt that is used to attach the motor to the gearbox. So we would want to select the number 10. We can do clearance, that's fine. I can hit the green check mark. And it has now added holes that are sized for the motor. All right, so just to recap a couple of things, in our master sketch, we have a gear that is intentionally sized to be 12 teeth and a gear that is intentionally sized to be 82 teeth. And then they are tangent to one another. And then we created a separate sketch that utilized those 2 parts to know where the center of the holes are, and we added some other material around it. We could have done a just big rectangle and that would have been okay, but I wanted to show you how we do some of this other stuff here. And then we extruded it, we added holes to be able to mount the motor. So the motor would be able to fit up top, and then this would be where a bearing could go for our spur gear and to be able to attach to other things. So I'm going to now go ahead and pause, make sure you get to this point, rewind, rewatch a couple of things as you need to pause whenever you need to be able to go and create this plate. We'll create a new assembly. I'm going to call this Andrew Gearbox. Whoops, this is a part studio. Let's delete this. I want to go back into Andrew, create assembly. Andrew Gearbox assembly. All right, so I can now insert this part that I just made, and then hit the green check mark. Normally, once we get further along, I want to show you all how to use this MKCAD app, where you could go and you can add all of the gears and motors, and they can be configurable. This is really, really great stuff here. But for today, if you've gone into the document already, I've added some parts into various assembly documents or tabs so that you can just go and insert them directly. So we will add an assembly from the insert. You're going to change to assembly here, and we want to use a 12-tooth sim pinion, an 82-tooth spur gear, and the mini sim. So I'm going to add those three things, hit the green check mark. I can go and move some things out of the way just so I can see where they all fit. And we can go ahead and start doing some mates. So go ahead and pause, make sure you get a assembly together with your gearbox, the mini sim, the 12-tooth, and the 82-tooth. Now that they are added, we can go ahead and fasten the gearbox in place. So we want to make sure that this hole of the motor is aligned with a hole on the gearbox. You can see that right now the primary axis is flipped, so we can hit this arrow to change the direction of it, and now it's all lined up. And we can add a revolute mate so that this motor can spin if we want it to. And we could do a couple of different things here. I'm going to see if I can get it so that it's at the center of this pinion. Maybe not. There we go. So that's the center of the pinion with the center of this shaft. You could do a couple of different things there. If you have trouble getting the center of the pinion, you could do at the end and then an offset to move it in a little bit. Or you can do what I'll demonstrate here, where you can take this, and I'm just going at the center of this face, and I'm going to align it with the center of the hole on this face. So I want it right there. And so this is also a revolute. I'm going to close out of here, and I'm going to fix part 1 because that's my gearbox. And so when I do that, what I should see is that the gearbox doesn't move. If I zoom in, I can rotate this pinion, I could rotate the spur gear, whatever, but you'll see that they don't rotate together. That's not super important, but we should see that the holes of this motor line up with the holes on the plates. What we could do if we wanted to, I just want to demonstrate this, is that you can do a gear relation. And so we can select this, and we can select the two mates for our gears. So I'm going to select Revolute 2 and Revolute 1. And this is a 82 tooth and a 12 tooth. So if I do 82 divided by 12 and hit the green check mark, I think hopefully here. Now when I move this a little bit, you can see that they now relate to one another. It's possible that when in your gear relation you need to change the order. So I have Revolute 2 and then Revolute 1, and then I did 82 divided by 12. If you've got them in the opposite order, you might need to do 12 divided by 82. This isn't really that important, but I wanted to show you that this is a thing that you can do. There are some instances where that might be needed. So now we've got it where we have fastened our motor to a plate that we made, and we can see that the spacing is very well lined up here. There's a couple of things that we would have to modify to make it so that the whoops, that's not what I wanted, where the teeth don't line up exactly with one another. That's not really a huge deal. I could maybe mess around with it a little bit. Nope, that's not what I want either. That's not a huge deal, so I'm not going to mess with that. We can see that the teeth line up. If I suppress this, I can right click and hit suppress, you can see that the teeth do line up very well here, so that we know that that spacing is pretty good. Normally what we would do is we would actually have an offset so that the pitch circles aren't tangent to one another. Let's say instead of this 82 tooth one, I wanted to right click and I can replace it with let's go to the assembly and let's select the 80 tooth spur gear and hit the green check mark. Now you can see we might have to remate things here. Let's change it. You can see that this is red because it doesn't exist anymore. Let's come over here and mate that and hit the green check mark. And you can see that now the gearbox doesn't actually work that great anymore. These teeth barely engage with one another, which makes sense because if we go into our gearbox here, we use an 82 tooth, but because we did it with a variable, I can go here and change 82 to 80, hit the green check mark, and now it automatically updated in our assembly, and these are now very well defined together. Or they mesh well together. All right, so go ahead and pause. You'll have to rewind and rewatch a couple of that. I'm trying to make sure to indicate some places to pause and do some stuff, but I'm still learning that I need to do that better, so I apologize. You probably should have paused a couple of times in there to get caught up. So go ahead and do that. Hopefully you've been able to attach a motor and a spur gear and a motor pinion gear together here with a very simple gearbox. If you want to go ahead and do the more advanced things of it, we could even insert the assembly intake that I've created. And I'm going to unfix part 1 here, and I'm going to instead fix this part of the intake real quick. So in an ideal situation, what's going on here is I'm going to use the fastened, and we're going to fasten this plate, our gearbox that we made, to the hole on our intake. So if I go here and hit solve, it moves everything over, or I can hit the green check mark here. So you'll notice that, okay, this is great that the gearbox kind of works, but we don't actually have any way that this is attached to this intake arm. So the next step would be to figure out how to adjust this plate in a way that you could have a couple of bolts that go through the 1x2 tubing here. There's a lot that you could do. We could do something where we just extend the plate along the 1x2 tubing over here and have 2 bolts, and that would hold it. You could do something where maybe you move both of these things over to the right and have a 1-to-1 gear ratio, so that it comes over here to the intake bar. But all in all, this is kind of just a start of how you do things together. And I hope that this is enough to inspire you to kind of mess around with it and figure out what it is that you would like to do. There's certainly a lot more advanced things that you can do. This is kind of just a start. So I'll go ahead and stop here for today. If you are able to create this plate based on these spur and the pinion gear diameters and have it where you have some holes for the motor to attach and create a small assembly that has the motor, your plate that you design, and these 2 pinion gears, or these 2 gears, you're doing a great job. And if you're struggling with that, that's totally understandable. So it's a little bit difficult when you're first getting started, but that's the goal or the objective for today. So I'm going to go ahead and stop here. Please rewind, rewatch, and do things along with me as needed in order to be able to get through it. Send any questions in Slack, ask our veteran students. We've got some really great students that can help you learn some of these things.
So that's it for today. Thank you.